Okay, so yesterday we learned about the radical function. So this is just normal. So a normal one, okay, obviously starts 0, 0, heads right up. Okay. Now, we have to think about our ABCD. So A's have to go in front of the function, in front of the radical, and B's always go in front of the X. Okay, so I'm going to call the 3 A, right? And this negative is in the B spot. Okay, so I have nothing doing C and D. So I'm already going to just put my starter 0, 0. Okay, so nothing changed that starter. Now, the over-up stuff, that's going to change. So normally we're going to go over 1, up 1, over 4, up 2, over 9, up 3. Okay, opposite of last year, because we did this idea when we squared, but now we're square rooting, so we're just oppositing it. Okay, so A, I'm going to have to times the up stuff, right, by 3, and I'm going to have to divide by -1. So I'm just doing the same stuff as when we did the coordinates, x divided by b. Okay, so negative, I'm just going to negate those. So I'm going to go left 1, up 3, left 4, up 6. Okay, so obviously you can see a reflection and a vertical stretch if you could physically think about those things. And we did lots of practice with domain and range yesterday. Okay, so flipping. So this is new. We are going to draw the radical of a given drawing. Okay, so f of x is just whatever is drawn here. Okay, it could be random things. Okay, so when we talk about f of x, we just keep saying it's a fancy way to say y. So this is what we're doing. We're square rooting the heights. Okay, our new coordinates, we're not touching the x values, we're keeping them lined up. But what are we doing? We're square rooting the heights on the graph. Okay, tell me, what can't you square root? Negative. Okay, so, right, I can't do anything with the graph down there because the heights are all negative. What would stay put if you square root it? 0 and 1. So invariant, invariant. Okay, that's important. And does anybody know what happens when you square root a decimal number? Like 0.5, the square root of 0.5 is 0.7. So that number is bigger. Okay, so that's going to go bigger than the original graph. I have to be above it. And then when you square root big numbers, they go smaller. So I'm actually going to line up the height of 4 here, and I'm going to change it now to 2 because I can square root 4. That's it. Can you answer domain and range questions when I ask you about this kind of stuff? Okay? In our domain, we couldn't go past -1 anymore, right? All right. So here we go. Where can I not do anything? Like all this stuff here, can't do anything there. Can't square root those points. What's invariant? Height of 0, height of 1. Okay, heights here are between 0 and 1, so decimal heights, when I square root them, they get larger, so you have to go above it. Okay, and again, I found a height of 4, so I dropped it to a height of 2. So I'm above, and here now I'm below. It did ask me to state the domain and range. So the range, the lowest height is 0 precisely, inclusive. And then you can go up. The domain we're going to write into 2 chunks. Okay? So starting from the left-hand side, I'm at -infinity. And I will travel till I hit, oh, I didn't do a very good one here, -1 point, I don't know what it is exactly, but sorry, I'm just going to just pick a number like it. Normally it would be a nice pretty number. Okay, and what it hits, okay, I know it's not that number, but what it hits will be an exact square. Union. Where do we start up again? So we stopped, couldn't, and then we could start again at +1.5 and then go to infinity. Okay, so this is the same question. It just says to draw it on the extra grid instead of on top of. Okay, so I'm not going to draw anything below there. 1, 2, 3, 4. 1, 2, 3, 4. Technically, I would have 1 coordinate there because that coordinate is okay. Then below, not good, not good. 0 will stay. Okay, so those are my invariant heights. Here I will have to be above. And that height, 3, 4, would be 3, 2. So that would technically be the graph. You'd have 1 dot there and then a little thing there. Did you guys draw an arrow? Because you shouldn't have if you did. Okay, why? Because my graph doesn't have an arrow on it, so I don't have an arrow on it. Okay, here's just a simple thing I see. Okay, so something like this, and then they like this is a problem that I often see. When they're trying to go above, look at what they did. They kind of like went too, they are existing. You shouldn't ever exist past that domain, right? So don't like hook it, okay? Make sure it's still lined up with the points. Compare the range and domain of this versus this. Okay, what is that? Where does that look familiar from in your past math? You gotta go actually way back. Not even grade 11 back. Before grade 11, grade 10, go all the way back. What is it? Okay, these are the things that you're supposed to know because you could run into things like this on the exam. It's a grade 10 idea. It's a line when you graph it. mx plus b. Okay, you learned that in grade 10. What are two things you know about this line? What's the 3 all about? The y-intercept. And when we do the mx plus b, what's the m going to represent? The slope. We have 1x, so you're going to go rise, run, rise, run. Did that kind of come back to you? On your exam, if you panic, what can you always do if you don't know the features of the graph? Plug in a table of values. Just go to the side and try to do some kind of table of values. A table of values always creates points. Once you see a few points, maybe you'll be like, oh, it looks like it's forming a line. Okay? All right, so what's the domain and range of that function? Both are infinite. Right? They're both. Okay, now, what if I square root that function? Okay, what are we doing here? Well, now we're chopping off that part, so that's going to affect our domain and our range. Invariant height, above on those heights, below those heights. So my domain got affected and my range, they both got affected. So here, now we're going to go -3. And 0. Okay, so this next one talks about invariant, and you're trying to figure out an invariant point of the original to the transformation. Okay, so we have to understand like what's invariant when we square root. 0 and 1, those are invariants, right? Okay, we can solve this graphically, we can solve this algebraically. So graphically, if I wanted to do that, hey, that's a line, -4. Slope is 1x, so 1. Make your staircases move by 1 up. If I wanted to square root that function, okay, no, this doesn't work. Oh, that would just stay put. That would just stay put. Above, below. So there's my answer. I have 2 answers possible. Which coordinates didn't end up moving? That was on the line, and it's on the little radical shape, right? What is it, 4, 0? And 5, 1. Those points didn't move. Okay. algebraically, you could have just thought about what's invariant. If the height is 0, how do you solve for it? Add 4. So x equals 4. Okay, but the question said an invariant point, so 4, 0. Okay, and same thing. You could have just done the algebra again here. You could have just put in, or the height is 1. Okay, if the height is 0 or the height is 1. Okay, so we had this question on the last transformation test, like, how do I know when a point doesn't move? Like, what do I need to see? I need to see a height of 0 or a height of 1, and then I know it's not moving, right? Okay, 2 more questions, and then we're done the whole radical thing. Okay, solve algebraically, and then we're going to graph. We're going to get a x-intercept. Okay, so algebraically, I'm going to square. Gone. Squaring makes 4. Subtract 3. X equals 1. So we should see on the graph, if we were going to graph it now, we should see that it's going to cross the x-axis at 1. Okay, so now we're going to graph it. Okay, so y equals da 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 da. I have a problem to start this out. What's the problem about how it looks when I go to write y equals? It needs to all be on one side, right? Okay, so I'm going to go y equals, and then I'm going to move that over. So when we have a function, everything's on the one side. What are the 2 questions I asked myself about graphing? Where should I start this? How should I move in a pattern? Okay, so there's a C and a D. So where should I start? Left 3, down 2. How should I move? There's no B, there's no A. So I'm just moving normal. Do you know what normal is? 1, 1. Reset. 4, 2. Ooh, it's good news for me. Okay. Guess what's funky on the test? When somebody answers me that their x-intercept is 1, and then on their graph it's hitting at something like 5. Okay, red flag. Your algebra and graph should match, right? Okay, here we go, last one. Solving. So I'm going to maneuver here. I'm going to add 4. I'm going to divide by 2. Now I'm going to square. And now subtract 5. Okay, so we're going to hope that the coordinate -1, 0 is on the graph when we graph it. Okay, so it was already on one side, so that's good. So I'm going to just do that graph. Y equals this function. So where do I start? Bless you. How does my pattern change? And it changes by a, what's that, an A or B? A. So my pattern changes like that. And then we're also gonna hope that we're gonna find out that it should cross at -1, right? So here I go, -5, -4. I'm gonna go right 1 up to, reset, right 4, up 4. Ooh, it did. It worked. It matched. Okay, I would expect a minimum of like those 3 points.